Okay, guys, so this video is going to cover notes 4-4. This is going to go over how we prove that two triangles are congruent, and this will be day one. So to start the notes off, it's going to be important to understand that we actually have 5 different ways to prove that two triangles are congruent. These 5 different ways are listed here in the table. So the 5 different ways I'm going to go ahead and highlight here, we have side, side, side congruence, we have side, angle, side, we have angle, angle, side, and we have angle, side, angle, along with HL. Those are the 5 different ways that we have to prove that two triangles are congruent. So to start off, the first one that we're going to look at is side, side, side congruence. So again, what we're looking at is how can we prove that two triangles are congruent? The first way that we can do this is if we look at the definition. If all 3 sides of two triangles are congruent, then that means the two triangles must be congruent. So here's what we're looking at here. If you pay attention here to what I'm marking here in purple, this side with one singular tick mark corresponds to, let me scroll back down here. This side with one tick mark is congruent to this side with one tick mark. So we can say that these two sides are congruent. You're going to mark your congruent sides with an S. So these two sides are congruent. Similarly here, the side with 2 tick marks is congruent to the side with 2 tick marks over here. So I'm going to mark this with an S as well, because these are congruent sides. And then lastly, the side here with 3 tick marks will be congruent to my side with 3 tick marks in the other triangle. And so when you label your sides with an S and your angles with an A, it's going to spell out the congruence theorem that we have. In this case, if you read around the triangle, it says SSS. Now, one important thing that I want you guys to write down, and it's listed here at the bottom, is we're going to take a look at how is it that I'm going to read these around the triangle, okay? So just an important note here, whenever we're reading, you're going to go around the triangle, and you need to understand that you can only skip one item at a time. And so when I say that you can only skip one item at a time, I'm going to show you what I'm talking about here. So let's say, for example, that I started at the purple side here. If I decided to read this going around the triangle, going this way, then as I travel from this purple S to the orange one, the only thing that I'm skipping right here is angle D. So I'm skipping one item, okay? And we'll get more clarification on this on how to read it as we look at these different congruence theorems here in the notes. Okay, but the main thing I do want you guys to write down here at the top is that this part's super important. When you're reading, you can only skip one item at a time. Super, super important. And we'll see how that works here in the next problem. So just to summarize here, if you have 2 triangles that have all 3 sides marked congruent, then we say the 2 triangles are congruent by side, side, side. The next theorem that we're looking at is known as side, angle, side. So this says that if I have 2 triangles, if we're looking at 2 sides and an included angle that are congruent in both triangles, then the 2 triangles must be congruent. So one thing I do want you guys to make note of here is the fact that we're looking at 2 sides and a included angle. So your included angle is going to be an angle that's in the middle, in between. So look at this A here. Notice that that angle has to be in between the 2 sides. So as I look at the example off to the right, notice that this side with 1 tick mark is congruent to this side with 1 tick mark. And we said we mark those congruent sides with an S. So this side is congruent to this one. Now, one thing I want you guys to do here is I want you to mark your congruent angles with an A. So these 2 angles are congruent, and we're going to mark them with an A. And then next we have this second side with 2 tick marks is congruent to this side with 2 tick marks. So there is another S. So as we're reading these, this is what I want to kind of focus on with you guys is how do I read it? Well, you can go one of two directions. So if I look at this first triangle right here, if I look at that first triangle, I can start at the green S or the orange S. And so let me talk to you about the two ways you can read it, okay? I can try to read it going from the green S to the orange S, but notice what happens. If I try to do that, what ends up happening is I'm skipping, and we're going to count here, I'm skipping this angle right here. That's 1. And then I'm skipping this side right here. That's 2. And then I'm skipping this angle right here. That's 3. I've skipped 3 items. The rule that we have when reading this is you can only skip one item at a time. So if I'm skipping more than one item going this direction, then that direction's not going to work. That means that I have to read it going the other way. So if I start here at the green S to go to the purple A, then you'll notice that I'm not skipping anything. I go from the side to the angle. So I go from the side, next I go to the angle, and next we have a side. Okay, so that spells out SAS. So that's how we're going to read these, and we'll practice more when we get to the examples. Okay, but this is what side angle side looks like, where we have an angle in between two sides that is marked congruent in both triangles. All right, the next one we're going to take a look at here is going to be known as angle angle side. So angle angle side, this is going to be when we're looking at two angles and a non-included side of two triangles are congruent. So non-included side means that that side is not in the middle. So take a look at this S right here. Notice how that side is not in the middle or in between the two A's. So angle angle side, if we go back to how we were labeling it earlier, start with angle F. Angle F is congruent to angle A. Those are congruent angles, so we mark them with an A. The next item that I'm looking at here is I see angle D. Angle D is congruent to angle B. That is another set of congruent angles, so congruent angles we mark with an A. And then lastly, I have side DE is congruent to side BC. Congruent sides we mark with an S. And so when you label it like this, again, when you read it going around the triangle, it's going to spell it out for you. And so we're just going to look at it this here. If I start at the green A, if I go this direction, what I see here is we have A, then the next item I see here is A, and then after that we have an S. So it spells out AAS. And then same idea here. If I start at the green one, I have A, then I go on to the next one here, I have AS. So it matches up in both triangles. These two triangles are congruent by angle angle side. The next one we're going to take a look at here is going to be known as angle side angle. And so what you'll notice about this one is that this angle side angle actually has the side in the middle here. So angle side angle happens whenever we have two angles and an included side of two triangles that are congruent. Remember, included just means in between or in the middle. So as I look at this and we start labeling it, let's go ahead and start here with angle B. Angle B is congruent to angle F. So these two angles in green are congruent. Next, we have this side in orange that is congruent to this side in orange. So I label it with an S. And then lastly, we have angle C is congruent to angle E. Those are angles, so I mark them with an A when they are congruent. And so when you read this, it's very clear that it spells out ASA. So these two triangles are congruent by ASA. And then same thing over here, ASA. So those two triangles are congruent by angle side angle. Now the last theorem that we're going to look at that you want to make sure that you pay very careful attention to is known as hypotenuse leg. So hypotenuse leg, something that I want you guys to highlight, circle, or underline is that hypotenuse leg will work for right triangles only. That is the only time you can use HL, hypotenuse leg. So this one says that if I have two right triangles, if these two right triangles have a congruent hypotenuse and a congruent leg, then the two triangles must be congruent. And so here's where I want to zoom in and just review with you guys really quickly here. So if you look at the reminder section, let me scroll back up there. Look at the reminder section. It looks like this is as big as I'm going to be able to get it. Your hypotenuse, so we're looking at this reminder right here. These are the parts of a right triangle. What is super important for you guys to understand is where your hypotenuse is located. Your hypotenuse will always be located across the 90-degree angle. So across the 90-degree angle, that is your hypotenuse. The other two sides represent your leg. So now that we have an understanding of the parts of a right triangle, we can take a look at how this works. And whenever you're answering these types of questions that we'll see in the notes, if you see that you have two right triangles, the first thing I want you to check for is, are these two triangles congruent by HL? So the first thing you look for is, I look for the hypotenuse. Remember, the hypotenuse is across the 90-degree angle. Is that hypotenuse marked congruent? If I look here, yeah, that hypotenuse is marked with two tick marks, and it's congruent to this hypotenuse in the second triangle. This is also a hypotenuse. So if that's a hypotenuse marked congruent, instead of labeling this with an S, we're going to label it with an H because this happens to be a hypotenuse. And then we take a look at the side that's marked congruent here, which I'm putting in green. This side in a right triangle is referred to as a leg, which we will label as an L. Okay, same thing here. That side is a leg, so I'm going to label it with an L. And so in this case, these two right triangles will be congruent by HL. All right, and so this will make more sense as we look at some examples here, but we talked about the 5 ways to prove that two triangles are congruent. Let's talk about the ways that do not work. And that's this last section right here. What are my ways that do not work for proving triangles are congruent? The 3 ways that do not work are listed here in the middle. If you get angle, 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 then that does not work. The other one that doesn't work, let me try to highlight here. The other one that doesn't work is ASS. And then lastly, the last way that doesn't work is SSA, which SSA is just ASS backwards. So these are the 3 ways. If you get something like this that pops up in a picture whenever you read it, if you get AAA, so AAA, or if you get ASS, which ASS is a bad word, we say that AAA and ASS does not work, okay? So we'll see examples of this that pop up in the notes where if that pops up, that means the triangles are not congruent, okay? Those ways do not work. The only ways that work are the 5 that we discussed earlier. So the 5 ways that worked were SSS, SAS, AAS, ASA, and HL. These are the only 5 ways that we have to prove that two triangles are congruent. So before we start looking at some examples, we want to talk about some important vocabulary here. So one term that you're going to see pop up a lot is something known as a reflexive side. So a reflexive side is going to happen whenever we're looking at a line segment being congruent to itself. So let me explain this in a way that's easy to understand. A reflexive side is mainly used when one side length is shared by two triangles. So if I take a look here, if I take a look at the picture off to the right, what you should be able to see here is that this side length, DB, that side length DB is shared by both triangles. Sorry, I'm trying to get this to line up perfectly here, and mine's a little off. So that side length DB is shared by both the top triangle and the bottom triangle. So whenever we have a side length that is shared between two triangles, we say that that side must be congruent to itself. And the reason for that is that it is a reflexive side. Okay, so your example here, and this honestly needs to get fixed here. This should say BD is congruent to BD. So again, a reflexive side is whenever you have a side that is shared between both triangles. If that happens, then we understand that that side is congruent to itself. So it's congruent in both triangles. The next thing we look at here in this last section of the table is an included angle. We've already talked about included, okay? Included angle just means that this angle is in between two sides. So for example here, if I look at triangle ABC, angle B, this angle right here, is an included angle which happens to be in between AB and between BC. So that angle B is the included angle. It's in the middle between the orange side and the purple side. Okay, so let's actually look at some examples here now so that we understand what are these problems going to look like. And before we move on, the last thing I want to re-emphasize here is what it says at the very bottom. What it says at the very bottom is when labeling and reading, you can only skip one angle or one side. You may never skip both at once. So like what we said earlier, you can only skip one item at a time. And we'll practice doing this in the examples. So in the first example, it says, determine if the two triangles are congruent. If so, by what theorem? I'm going to write the ways that work here at the top. SSS works, SAS works, AAS works, ASA works, and HL. These are the 5 different ways that are able to prove two triangles are congruent. So as we do these problems, we're going to check, after labeling, does it give me one of these 5? Okay, and then just to also put this at the top here, remember that AAA, ASS, and SSA, these are the ways that do not work. Okay, so I'll mark this here with a red X here. If you get one of these, does not work. Okay, so if I look at number 1, okay, what I see here is that this angle right here and this angle right here are congruent. So if they're congruent angles, please mark them with an A. What I also see here is that the angle marked with 2 rings is congruent to this angle marked with 2 rings. So right now I have 2 angles that are marked congruent. What I want y'all to pay very careful attention to is look at this side right here in red. That side is shared between both triangles, so that side is going to become congruent to itself. So because that's a side, we mark it with an S. So when I read this, okay, what I'm comparing is the 2 triangles. So I'm looking at this green triangle and I'm looking at this yellow triangle. Are these 2 triangles congruent? Well, yeah, let's read it. If I go around, and so let me explain to you on how it is that we're going to read this. So if I decide to start with this purple angle A and the green triangle, you have 2 directions you can go. I can go this way, or I can go this way. So let's see what happens if we try to go this way, from the purple angle to the green one. If I try to travel across there, what ends up happening is that right now we're going to count how many items we're skipping. Right now I'm skipping this side right here, that's 1. I'm skipping this angle right here, that's 2. And then I'm skipping this side right here, which is 3. Remember, you can only skip 1 item at a time. So if I'm skipping more than 1 item at a time going this direction, then that tells me I can't go that way. I have to go the opposite direction. So in other words, we're going to have to go from this purple angle this way. And if we go this way, let's see what it ends up spelling out. What I see here is I go from A, S to an A. And what I see here is that that actually matches up with this one right here. I just need to make sure that that also matches up in the second triangle. If I look at the second triangle here, I can see here that if I start at the purple one, I can't go this way. because I'll skip more than one item. So I have to go the other way. That'll take me and get me to the red S and then the A. So notice how both of these spell out ASA. So your answer for number one, determine if the two triangles are congruent. If so, by what theorem? You're going to say the two triangles are congruent by ASA. Okay, and that's how we do these problems. This is how it is that we read it. So let's go through number two. It says, determine if the two triangles are congruent. If so, by what theorem? The first thing I'm going to notice here is that these are right triangles. We said that if we have a right triangle, the first thing I want to check for is HL. So I'm going to check here, did they mark the hypotenuse congruent? Remember, the hypotenuse is across the 90 degree. And I see here, yeah, they absolutely did. They marked this hypotenuse congruent with 2 tick marks. And they marked this hypotenuse congruent with 2 tick marks. So what I'm checking for now is, did they mark a leg congruent? Well, yeah, this single tick mark is a leg, so it's congruent to this one. So as I see here, when I read this, it spells out HL. So my answer here is that these two triangles are congruent. By what theorem? They're congruent by hypotenuse leg, by HL. All right, let's look at a few more here and we'll kind of go through these a little bit faster. So now it's asking me for number three, the same thing. Determine if the two triangles are congruent. If so, by what theorem? So I'll go through this a little bit faster. We see that this one single ring is going to be congruent to this one single ring. So that's a congruent angle. I mark it with an A. Next, I see that I have 2 rings here. So this angle is congruent to this angle. And I see that I have a side that is marked congruent here, and a side that's marked congruent here. So these are the challenging ones because you have to read this carefully, okay? My only 2 options on where to start, if I'm looking at these 2 triangles, okay, so I'm looking at this yellow triangle, and I'm looking at this green triangle. I have to start in the yellow triangle. If I start reading this, I either have to start at the purple angle or the green side. I cannot start here in the red angle because it's in the middle. You never start in the middle. You start at one of the ends. So I'm going to start here at this purple angle. Let's kind of see again the 2 directions I can go. I can either go this way when I read it around the triangle, or I can go this way. If I try to go this way that I just marked here, we're going to count how many items that we skip, okay? If I go this way, I'm skipping this side right here that I have circled, and I'm skipping this angle right here. So I'm skipping 2 items. I cannot skip more than 1 at a time. So I can't go that way. Have to go the other way. Have to go this way. So if I go the other way, then I'm noticing here that from this purple angle to the red one, I'm only skipping 1 side. That's okay. You can skip 1 item. So next, that takes me to A. And then if I keep going, it takes me to S. So what that's looking like for me right now is this is looking like AAS, which if I look here, that happens to be one of the options that works. I just have to make sure that it matches up in the second triangle. If I look at the second triangle, it reads AAS. So my answer here is that these 2 triangles are congruent by AAS. Okay. Next, we have number 4. Determine if the 2 triangles are congruent. If so, by what theorem? So one thing I want to just automatically start with, I like to start with what's already marked. This angle here is congruent to this angle here. I see here that this side with 2 tick marks is congruent to this side with 2 tick marks. And then what I notice here is, look at this green side right here. That green side is shared by both triangles. So that green side must be congruent to itself, meaning that that side is congruent to this side here and the other triangle. So I'm looking at these 2 triangles, the one in yellow and the one in green. Are these 2 triangles congruent? If I read the triangle in yellow, this one spells out, I'm going to write it off to the side here. The triangle in yellow spells out SAS. Spells out SAS for the yellow one. If I look at the green one spells out, if I start here at the black S, it spells out SSA. you'll notice that these two do not match. If they do not match, then that means these two triangles are not congruent. And that's always a possibility. And you'll also see here, look right here. Remember, ASS was one of the reasons that do not work. Okay, we'll look at a few more examples, then we'll finish up here. So statement number 5 says, determine if the two triangles are congruent. If so, write the congruency statement and by which theorem. So what I notice here is that, look, boom, this side is congruent to this side. This double tick mark is congruent to this double tick mark. And then lastly, this triple tick mark is congruent to this triple tick mark. So what I see here is I read around the triangle, I have SSS. If I scroll up here, yeah, SSS works. So if SSS works, then I can say these two triangles are congruent. They're congruent by SSS. Okay. Now, one thing I want to bring your attention to is that this question is slightly different. It says determine if the two triangles are congruent. We did. We just said they're congruent. But now it says, if so, write the congruency statement. I'm going to show you what a congruency statement is. A congruency statement is something you guys have actually already seen before. So a congruency statement is going to be writing a statement that has a congruent symbol on there. So in this case here, let's say that in this triangle to the left, I'm going to call this triangle, I'm going to do this in a different order here. I'm going to call this triangle BCA. Triangle BCA. What I'm looking for is, what would that triangle be congruent to? Obviously the second one, but I need to be very careful on the order because the order matters here. So the first letter that we start with here is B. Okay, look at B. Angle B is in between the red and the green. So B matches up with Y. Y is in between the red and the green. So this will match up with Y. Next, we have C. C is right here in the first triangle. C is in between the red and the black. So in between the red and the black would be Z. So the next letter I have is Z. And then lastly here, we see here that my last letter here is A. A is in between the green and the black. A matches up with X, which is between the green and the black. So YZX. So my congruency statement is this part right here. This is my congruency statement. And for these, I'll normally fill out the first part for you. Okay, your job is to make sure you match it up and put it in the correct order. So be careful. Please slow down when you get to the congruency statement. All right, so next we'll look at number 6. Same thing. Determine if the two triangles are congruent. If so, write the congruency statement and by which theorem. So one thing that we keep seeing popping up a lot is I'm seeing here that these angles right here, we call these vertical angles. And we know that vertical angles are congruent. So look, this angle right here is congruent to the other vertical angle right there. And I see here that I have this side congruent to this side. And then lastly, we have the 2 tick marks side congruent to the 2 tick mark side. If I read this, guys, this is going to be congruent by SAS. And before you kind of answer whether it's congruent or not, check to see if it's on the list. If I scroll up here, SAS, yeah, it is. That way works. And that way is coming from your table, right? We did SAS right here. So that works as a way to prove the two triangles are congruent. So we know they're congruent. Now what we have to focus on is write the congruency statement. So my congruency statement would, let me start it off for you guys. Let's say that this will be, let's do XVW. XVW would be congruent to, well, let's match it up here, okay? X is the end from, if I look here, I have the red angle and the blue side. X is at the very end of that. So X here would match up to the red angle and the blue side end with Y. So this would be congruent to triangle. We start with Y. Again, it's a matching game. Please slow down here because a lot of people make mistakes here. Next we have V. Okay, V is going to be this red angle right here. So matches up with this red angle, so V. And then we only have one letter left. Only letter left I have here is W. W is with the red and the green. Red and the green matches up with Z. So my congruency statement is that triangle XVW is congruent to triangle YVZ. All right. 7 and 8 are similar, but this time they didn't mark the pictures for you. We have to mark it. So let me scroll down here. So number 7 says, if C is congruent to F, as I read these questions, I'm going to start to mark it. So if C is congruent to F, so C congruent to F, that is a congruent angle. We'll mark it with an A. Next, it says angle A is congruent to angle D. So I'm going to mark this with 2 rings. A is congruent to D. So that is another congruent angle here. And then lastly, it says segment BC is congruent to segment EF. So here's BC congruent to EF. So that side is congruent to this side here. Okay. If I read this going around the triangle, I see that it spells out AAS here, and in the second triangle also spells out AAS. So AAS is one of the ways that works. So these two triangles are congruent by AAS, angle, angle, side. I just got to make sure that I get the correct order here. So I start off with C. If I look at angle C is given by the red angle. So C matches up with F. So I start off with triangle F. Next, I'm looking at B. B is the angle that is not marked. The angle that is not marked in the second triangle is E. So next I have E. And then lastly we have A. A is the blue angle, matches up with D, the blue angle. So triangle FED is how I would finish that congruency statement. Next we're looking at segment number 8. I'm looking at, it says line segment AD is the angle bisector of angle BAC. So angle bisector, we're going to talk about what it means to be an angle bisector. We know bisect means to cut in half, right? So what am I cutting in half? I'm cutting in half angle BAC. Here's angle BAC. That top angle right there, it's getting cut in half. So if that angle is getting cut in half, that means that these two pieces here would be congruent. So I'm going to mark that with an A. These two angles are congruent. The next part says that BA is congruent to CA. So BA is congruent to CA. These two sides are congruent. And then one thing that I do not want you guys to forget is if I look at these two triangles, you can see that they both share this side in the middle. They both share this green side here. So that side will be congruent to itself. So as I fill that out there, that'll be a congruent side there. So as I read this or going around both triangles, it spells out SAS. So these two triangles are congruent by SAS. We just have to finish the congruency statement. Triangle DAB, and we've done this enough times to where you should hopefully be able to do this a little faster now. Triangle DAB will be congruent to triangle DAC. If you need to slow down and use the highlighters, you're more than welcome to do so. But for time's sake, let's move on to number 9 and 10. So for number 9, now it's asking you what additional information is needed to prove that the two triangles are congruent by ASA. So I want to have ASA. So let's mark what we have in the picture already. What I see that I have in the picture already is I see that this side is congruent to this side. Okay, so I have the S taken care of. What I also see is that I have vertical angles right here. So that takes care of an A and an A. So look, I have the AS taken care of. What information is missing here? What I'm missing is, I'm missing this angle. And I need this angle to be located in a place where the side is in the middle. Okay, so where is this congruent angle going to have to be so that the side is in the middle? The location of that congruent angle must be located here. I would need it to be here to have that side in the middle. So the missing information that we need here is, what we're missing is we would need angle C to be congruent to angle T. That is the missing information to complete ASA. And we'll finish up with 10 here. What additional information is needed to prove that the two triangles are congruent by side, side, side? So I want to have side, side, side. Let's see what we have already. Okay, look at QR. QR is congruent to RV. That takes care of one side. Now what I also see is, look at this side right here that's shared between both triangles. So that side is congruent to itself. Takes care of another side. What I'm missing right now is I'm missing a third side here. I need a third side to complete the SSS. Because if I look here at the picture, I didn't mark it, but in blue, this is a side congruent to this side. In green, this side is congruent to this side. I'm missing a third side. That third side that we're missing must be this one here in red. What I'm missing is let me scroll down here. I need PQ to be congruent to PV. Okay, and so that'll complete the notes. I know that today's notes was long and it was a lot to go through in one day of notes, but I really need you guys to try to do some of the problems from the homework. The homework can be found on Canvas. If you guys would like to write out the problems and draw it out, use highlighters, different colors if that helps. I highly encourage you guys to do that, but please at least try the homework so that when I come back, we can go over some of those problems together.